Today, what we're doing is we're going to be working on finding angles given that we have two sides. So, what are we doing today? This is what we're doing. Given two sides, we can find one angle. How do we know we understand? One, basically what you really need to realize is that we have labeled the correct sides based on the angle that we've chosen to calculate. Two, we use SOHCAHTOA. To determine those sides. And then for three, we use the inverse to find the angle. That's all you need to know. Now, basically, we'll just go over all this information right here. When we're using trig to find angles, basically we follow the same steps as before, and we always use the inverse ratio to find an angle. Now, we don't round the final answer. We therefore use the wholest degree. So now what we're going to do is we're going to move on to our problems for the day. Now, the first thing that we have to do is we have to identify the side that we're looking for. In this case, we're looking at angle A here. So for angle A, we've got this angle that we're looking for. We now need to label all the sides as opposite, adjacent, and hypotenuse. So this part here is our adjacent, this part here is our opposite, and this part here is our hypotenuse. Now, from here, just like we said, we must, one, label all sides. And then basically for our second set, what we have to do is we have two. We're going to use SOHCAHTOA. And then three, we're going to use the inverse. Now for this problem here, we have two sides that we have, and we're going to use those two sides to find this angle. So the opposite and the adjacent is the TOA in SOHCAHTOA, which means that it is tan. So now we have the following calculation. Doing appropriate substitutions, we get the following. And now we solve for A using tan inverse. So, in order to do this calculation, we're going to call this word here the tan inverse. Now, for this calculation here, in order to calculate it, we have to use the second function or the shift. So I'll actually write what we have to use. So we write on our calculator the following. We're going to write shift. We're going to hit the tan button to invoke the inverse, and then we have to use brackets to surround our information, and then we go 14 divided by 9 end bracket, and end the bracket. And that calculation will give us the following answer. A is 57 degrees. And please remember, we always compute angles to the nearest degree. What I'd like you to do is stop the video, and I'd like you to try question B, and I'll put the solution up to that in a minute. Based on our angle, we have two sides, and those two sides are the adjacent and the hypotenuse. So for the adjacent and the hypotenuse, we're going to use cosine law, which gives us this. And upon substitution, we get the following. Inputting the information into our calculator, we get the following. So we get B is equal to 50 degrees, and your homework is indicated here. Page 24, number 4, 6, 7, AB, and 14. And basically, that information is on the Schoology website, so if you don't have the textbook, you'll be able to do the questions. Okay? Take care. Now, remember that we talked about solving triangles a while back. Solving triangles means finding all the missing parts of the triangle. Now, every time we do these problems, you need to remember that we must, first of all, find the angle. Now, like I said a long time ago, every time we're doing these sine and cosine and tan type problems, we always have to label the sides. In this case, I'm going to identify that we're going to use P as our reference angle. And so what we're going to do next is we're going to label all our sides as opposite, adjacent, and hypotenuse. And now that we've done that, the next thing that we should do is we should label all of the sides by their small letters. In this case, we have small r, q, and little p. Now, just like I said in class, anytime we're dealing with trig problems, we have three things that we can work with. We have two sides and an angle, always. And all we need is two of those three things to figure out what we're doing. In this case, we have two sides. Notice the two sides have been labeled with 6 centimeters and 8.2 centimeters. Now, because the 8.2 and the 6 are referenced by hypotenuse and adjacent, if we write SOHCAHTOA above, since we're all visual, and if we see those things, we can decide, because we have the adjacent and the hypotenuse, that means we're going to use cosine. So now we're going to go and find the angle. We'll start by writing our trig identity. Cosine theta is adjacent over hypotenuse. And now we'll do our substitution. Rearranging to find for p, we get p is equal to cos inverse 6 divided by 8.2. Punching that in our calculator, we get p to be 43 degrees. Remember that all degrees are supposed to be in single units, no decimals. And now let's move on to part 2. Now, since we found that we have 43 degrees for P, I'm going to write that on my triangle. Now remember, we have to solve for that. Now the easiest thing to do would be to find the opposing angle. And to do that, you need to remember that the internal angles of a triangle total to 180. So we have this, which gives us the following. Just going to take a minute to remind you. You'll notice that we have an angle of 43 and an angle of 90. The total interior angles of a triangle is 180 degrees. So when we find the angle R, we must subtract 90 and 43 from it. And now we'll move on to our final calculation. For part 3 of this lesson, we still have one side missing. So let me, before we go on, write in my angle of 47 degrees. Now, there's only one side missing. Notice it's P. So we're just finding the smaller side. Now there's two ways to do this. We can find it through Pythagorean Theorem. Now, since P is one of the side legs, we actually have to take the hypotenuse, which is 8.2, and subtract it from 6 squared. Then we basically square root, get our answer, and we end up with 5.6. Now, there is another way of doing this. Now, remember, so in this case, we can use one of the other trig identities. So remember before we had so, ka, toa. Remember in step 1, you used cosine to start. Now, because we used cosine to start, that allowed us, once we did all of our other calculations, that allowed us to go either use sine or tan to find our final answer. Oh, don't forget, always make sure that you write your answers on your triangle so I can see what they are. So in this case, I got 5.6 centimeters for P. Now, remember what I told you. We already used cosine to find one of the angles, so that means we can use either sine or tan to do so. So here's what you do. I'm going to use sine. So in this case, I'm going to use sine because I just feel like it. If you recall, our original sides, remember the original sides from the triangle were 8.2 and 6. So I would tend to try this one because I have the originals on the graph and I didn't do a calculation with the other. Tan would require me to do a calculation with something that I calculated. If I made a mistake, problem would have happened. So I'm going to use those angles and sides. So sine of theta is equal to op divided by hypotenuse, which is, well, let's see, the op, we don't know, we call that P, and our hypotenuse is 8.2 sine, and we found our angle to be 43 degrees. So because P is on the top and we're looking at the hypotenuse on the bottom, we just multiply across. Anytime P is on the top, or the variable we're looking for is on the top, we just multiply the two. So now we have 8.2 sine 43 is P. Finding P, we end up with, guess what, 5.6 centimeters. And we're done. A lot of you like to use Pythagorean Theorem. That's not a problem. Some of you may be a little bit more sophisticated, so you could use sine to do it, or tan to do the calculation. Either way is perfect. Now, the specific questions that pertain to this type of problem are 7a and b on the worksheet that I gave you for this lesson. Now, I had already given you solutions to questions B, but I'll go over it and just show you the solution as the last slide for this presentation. And please remember that you're working on the current worksheet, page 24, 7AB, which pertains to finding all sides of a triangle and angles. All right, good luck.